Okay, welcome back. So this will be the first actual piece of calculus that we'll get into. Should have seen something about this in pre-calc. Probably will have two videos, maybe even three on limits. So for part one of limits, we're going to just be asking what is a limit? And I try to keep the definition as simple as I can. Obviously, there are very math-based definitions we can look at in a textbook. But for what we're interested in right now, a limit is as x, your x value gets very, I'm going to go with two of those to emphasize very, very close to a value. What is the corresponding y value? As x gets very, very close to a value, what is the corresponding y value? That's for right now what we want to be thinking about when we hear the word limit. So we're going to start extremely simple and basic, and as we go through, they get much more complex. But to come up with an idea of what this means, I start with a graph, and we're just going to draw something as simple as this. We'll put a dot there. Let's put some numbers to it. We'll say that's 2. That corresponding spot is 3. And then we also need to come up with some notation. So we'll say this is the function f of x, and we are going to look at the limit as x approaches 2 for the function f of x. Okay, so when I teach this, I introduce my two guys, and I draw two people on the x-axis. And we have one guy that comes from the right, and we have one guy that comes from the left. And these two people are going to run, hypothetically, to whatever value we're interested in. So as these two guys would start approaching the number 2 from each direction, we have to keep in mind that simultaneously, there's function values that tie into this graph. So in other words, if the guy from the left is running, and let's just pause him and he's right around here, his corresponding y value is up here somewhere. As this guy runs from the right, and as he's getting closer to 2, his corresponding y values are approaching, and they're always tied into the function. And we always want to think of these two guys that are running as never leaving the x-axis. So as these guys get closer and closer and closer to 2, remember our definition we just said a second ago, a limit is as x gets very, very close. It never quite gets there, but it gets so close that we're pretty much there. So as these two guys get extremely close to the number 2, they're so close that now we're at like 2.001 and we're at 1.999, whatever super close means to you. And as these two guys get extremely close to the number 2, hopefully it makes sense that their corresponding y value would be tied in to the number 3. So for that reason, we would say the limit as x approaches 2 is equal to 3. As x gets very close to a value, what is the corresponding y value? Okay, next, what if we looked at something that looked like this? And we're going to draw a graph. We'll call that 2. We'll call that 1. Let's call that 3. So something like that. This opens us up to some different questions. Let's say that we had the limit as x approaches 2, and now we're going to introduce a symbol with a plus sign, the limit as x approaches 2 with a negative sign, a limit as x approaches 2, and we're also going to look at f of 2. And this is all for the graph given f of x. So that is this graph. This graph is f of x. Okay, so new symbols here. When you have a plus or a minus symbol, this means specifically only from one direction. So if it's a plus symbol, we are only interested in this limit from the right. I'm only approaching 2 from the right. So as this guy would approach 2, getting closer, 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 his corresponding y values, hopefully it would make sense to say they're getting closer and closer to 3. As we approach this from the left-hand side, this would be getting closer, closer, closer to 2. We're never going to quite get to 2, though. So we never quite get there. So you never quite get to this open dot. You get extremely close to it, though. So as we approach 2 from the left-hand side, this guy would be running. He would get extremely close to 2. The corresponding y value would get extremely close to 1. Okay, if you do not have a direction stated, then both guys are going to run. And as we just showed up here, they come up with two different answers. If they come up with the same answer like they did up here, think of this as limit from the right was 3, limit from the left was 3. They agreed, so that was your answer. If they do not agree and you come up with two different answers, then your result is D and E, and that stands for does not exist. Okay. And for the last one, f of 2 is not a limit question. F of 2 means you have made it to 2 and you're interested in what that result is. And that result would be 3. So the limit as x approaches 2 would be 3. Okay. So obviously we can come up with all sorts of graphs. You will find more of these in class and on study guides. You can go to Google. I mean, that's the idea though, left, right, and then all together if there's not a direction. Okay, so what if we have something that is written like this? The limit as x approaches 1, and you're not provided with a graph, but we tell you it's 2x plus 1. Okay, so a couple things here that we could do. First off, you could graph this. Hopefully we know how to graph the linear function 2x plus 1. If you went and graphed that, that would be what? A y-intercept at 1, and then a slope of up 2 over 1, and you could go on and on. And that graph would look like this. So that as you approach 1, hopefully it would make sense. Remember, there's no direction here. Hopefully that would make sense to say that that result ends up being 3. Now, what if you had absolutely no idea how to graph that function, and we were still trying to come up with this answer? Well, it might make sense to you to say that how else could we come up with 3? You could do it by plugging in the number 1. So that seems really easy, and it is, which means that's not going to work too often. But it's going to take us to our list of strategies. So I call it the ways to solve a limit, or our list of limit, whatever you want to call it, strategies, ideas, tricks, whatever. So coming in at number 1, what we just did a second ago, if you can plug in, well, that is very nice. Go ahead and do that. You would get an answer. If you can't plug in, what does that look like? So coming in at number 2, what if we had this? The limit as x approaches 3 for x squared minus 9 over x minus 3. Okay, here's your answer as to when you can and cannot plug in. If you plug in a 3 in this case, it makes the bottom of the fraction, the denominator, it makes it equal to 0. You cannot plug 0 into the denominator and make that undefined. If that is the case, we've got to come up with a different strategy. And there's a whole bunch that's going to be on this list. So hopefully it would make sense to you guys, though, to say, hey, this looks like something that would factor. And this would factor into x plus 3, x minus 3 over x minus 3. So strategy number 2 is factoring. Can I factor this? And here's the story. If these cancel, that is good. And then you are allowed to plug in to what is left. And if I plug 3 into what's left, that would give us 6. Okay, visually, in case you were curious, you don't have to do this, but if you wanted to know what that looked like, what would this graph look like, this original graph that we had? Well, when you factor this, this cancels, and we need to know what that means from pre-calc or algebra 2. When you cancel a quantity, that creates what's called a hole in the graph, and there should be a hole in the graph at x is equal to 3. The hole in the graph is always at whatever makes the thing that you canceled equal to 0. So if I put 3 in, that would be the hole for this graph. So you graph what's left. So we're going to graph x plus 3. X plus 3 would be a y-intercept of 3, and then a slope of up 1 over 1, up 1 over 1, up 1 over 1, and so on. And if you do that 3 times, now what did we say was going on at 3? There was a hole in the graph. So pretend that's a straight line. That was my best attempt. And if you look at this visually now, what is the limit as x approaches 3? If you send your guys from both sides, as you get close to 3 from both sides, remember, you never quite get there, but the closer you get to 3, the corresponding y value is in fact 6. Now, are we going to be graphing all of these by hand? No, because realistically, we want to just get to the answer as quick as we can. I'm just kind of trying to provide you some background story to hopefully make sense of that. But in terms of what we can do right now, we want to try, can I plug in? If not, okay. Can I factor? If yes, perfect. Do that. Factor, cancel, plug in. If not, coming in at number 3 is, did they provide me a graph? Do I know what the graph looks like? Is this something that I can analyze visually and come up with an answer that way? So that's going to take us to the next part. And there's some special, there's no real name for this. I call them special calculus graphs. And they just tend to pop up throughout the year a little bit in calculus. So there's 3 of them that I highlight for you guys that I think you should know. And that is y is equal to the absolute value of x over x, y is equal to 1 over x, and y is equal to 1 over x squared. Now, if you want to go through and figure out on your own how these graphs come to be, you could you could use a calculator or Desmos. The other thing you could do is you could make a table, an XY table, start plugging stuff in, and you could kind of prove it to yourself that way. For time's sake, I'm just going to provide you the graphs. You're welcome to explore on your own if you want to see where they come from. But for the first one, this is what it turns out to be. And so then you could see, in this case, we could answer limit questions from the left, from the right, all together would be D and E, and so on. This second one, this is 1 over x. It looks like this. And the third one looks like that. Now, these are very unofficial names, but we always in class kind of struggled to identify. People wouldn't remember, 1 over x, or so we came up with a name for them, just an unofficial name. And we refer to these as the broken ruler, the branches, and the volcano, just for the sake of having something to call it. Just like if I say parabola, that should signal a shape in your mind. So just in terms of our class, if you hear us say these words, hopefully it kind of triggers this graph for you. So feel free to pause this video, kind of copy these down. So obviously I can ask you limit questions from these 3 graphs. So we could say from the left, from the right, so on and so on. So let's go through and try some of those and see what we come up with. So I am going to give you a whole bunch of limit questions, have you pause the video, and then go through and try them. So let's look at make that a minus. All right, let's have you pause the video again. That is a minus there. Sorry, I changed my mind on the fly. Let's have you go through, pause this video, and try to identify 5 answers to this. And then when you come back, we will go over answers. Okay, so for the first one, hopefully it makes sense to say that one would factor. So I'm going to just slide down here to put answers down. So for number 1, if you were to factor that, that's the limit as x approaches 2, and then that would be for x plus 2, x minus 2 over x minus 2. The x minus 2's would cancel. You could plug in 2, and that would give you 4. For number 2, if you plug in 0 from this, now we got to think about it. Can I plug in 0? No, but we should know that that graph is branches. So that graph looks like this. And as we approach 0 from the right-hand side, that would give us an answer of 1. For the third one, that graph was 1 over x. So that is our branches graph, as we approach infinity. Okay, now, so that's our first time talking about that. Which way is infinity? Positive infinity is down here, right? My numbers go 10, 100, 1,000. We head to the direction of infinity. And as you head to the direction of infinity, this graph is going to get extremely close to the number 0. Also, see if that would make sense to you. As these numbers get bigger, as I plug in 10, it's a tenth. 100 is 100th. 1,000 is 1,000th. As this number gets extraordinarily big, 1 over a very big number is very, very close to being the same thing as 0. Okay, in number 4, what graph are we looking at there? That was the one that we called volcano. Okay, and in this case, we said we were heading to 0 from the left. As I head to 0 from the left, that thing just keeps going up and up and up and up. So we can say that that y value would be approaching positive infinity. For the 5th one, number 5, that is something that factors. What kind of factoring is that? That's sum or difference of perfect cubes. So if you do not remember that, you'd have to refer back to the video on factoring. To factor that, this is the limit as x approaches 3/2, and then we're going to factor this. So it would be 2x minus 3, 4x squared plus 6x plus 9 over 2x minus 3. So we could cancel these out. Take note, we were not able to plug 3/2 in to begin with. If you plugged 3/2 in to begin with, that would have zeroed out the bottom, which meant we had to factor this. So if we plug in 3/2 to this, this would be 4 3/2 squared plus 6 times 3/2 plus 9. And what does that give us? If you square a fraction back from our exponents video, hopefully that makes sense to say that that would give you 9 over 4 plus 6 times 3 over 2 plus 9. What does that give us? 4 times 9/4 is 9. 6 times 3/2 is 9. That last number is still 9. That gives us a grand total of 27. Okay, so that is part 1 of limits. I'm thinking this is going to be probably a 3-part series of videos. There's a lot to cover with limits, but in this particular video, we have talked about you can just plug in, you can factor, and how special graphs work, or if you are provided with a graph, how to read that. So hopefully this makes sense, and I will see you guys in the next video.